we'll start with IO interface or the companion chip 8255. This particular chip 8255 is also called as Programmable Peripheral Interface or PPI. The basic purpose of 8255 is to provide an interface between the microprocessor and any IO device. Like in the previous class, we saw if I want to connect any IO device, whether it is as simple as your switch, LED, or as complex as your keyboard, touch screen, it needs to be isolated or kept isolated from the microprocessor. Yes, it should come in use only when needed. Otherwise, it will be transferring garbage data to the processor all the time. Yes, so any IO device, when we are connecting it to the microprocessor, we cannot directly connect it to the system bus. Yes, it has to be connected through an interface. That interface could be a buffer, could be a latch. Now, depending on every input device, instead of designing every time one particular input interface, which is your buffer or latch, we can take help of your 8255, which is a programmable peripheral interface. Yes, or in general we call it as general purpose port. Yes, so it behaves as a interface, is a port between the processor and your IO device. So you can program your 8255 to behave as an input port, to behave as an output port, or in both mode as well. Yes, that is why it is called as programmable. So you can program 8255 to behave as a specific interface or as required as the specific interface between the microprocessor and your IO device. So we'll see in little detail of 8255. So basically 8255, this is the pin diagram. Instead of this, I'll go to this particular diagram, which shows completely the internal architecture of 8255 and the important parts or functions of 8255. So if you see, whenever we say I am using a interface, yes, it have two sides. We have two sides of an interface. Yes, one side the interface is connected to the processor. On the other side, the interface is connected to the IO device. So any interface we are considering, it have two sides, yes, of connection, or you can say two sides of the interface. So if you see in this case, we call where the IO devices are connected are called as the device side of the interface. This is your device side of the interface, and the other side where the port is connected to the microprocessor is called as the system side of the interface. This is your system side of the interface, and this side is the device side of the interface. That means the interface or the port is connected to the system or microprocessor with this set of pins, and the interface or the port is connected to the IO devices with this set of pins. Yes. So first of all, 8255 is having three 8-bit ports. The first thing to understand is 8255 is a general purpose port and it has three 8-bit ports. They are named as port A, port B, and port C. Yes, port A, all these are 8-bit ports. That means it can communicate 8-bit of data. Yes, 8-bit port, we have discussed previously. Port have two parts. One is the device size or the type of port, whether it is a data size, it is able to transfer 8-bit port or 16-bit port, and then the other part is address of that particular port. Port address and data transferred by that particular port. Yes, whenever we write in and out instruction, we have two parts. One defines the address, port address, the other defines the port size. Size means the size of data it is able to transfer. So here we have three 8-bit ports. Port A, Port B and Port C are three 8-bit port. That means it can transfer 8 bit of data. Port A can transfer 8 bit of data. Port B can transfer 8 bit of data. Port C can transfer 8 bit of data. You can connect 8 bit of input or output device. I can connect 8 bit of input or output device to 18255. Yes, because it have port A, 8-bit port A. So let us assume I am connecting 8 LEDs to port A. I am connecting 8 switches to port B and another device which is a 8-bit device to port C. Yes. So in this way you can see that we can connect 3 8-bit IO device through 18255 chip. Yes. So it contains 3 8-bit ports, and if you see one of the port C can be broken up into 2 4-bit ports. Yes. So this is further division is possible only with port C. Like in a microprocessor, you have seen some first four general purpose register can be broken up into smaller registers. Yes, AX can be broken up into AL and AH. Similar concept is here. Here we can see that port A, port B and port C are three 8-bit ports. But out of these three 8-bit ports, port A can be used as 8-bit port alone. There is no other option for us. Port B can be used as an 8-bit port only. But port C can be used as a 8-bit port or can be broken up into two 4-bit ports. Upper port C, lower port C. Yes. So this port C, if you see, we have broken up into two parts or two halves. One is called as upper port C. It will contain the upper 4 bits of. So if I am naming them, each of these port are 8-bit port. I have named them at PA0 to PA7. Port A having 8 bit of data communication or data transfer capability, and the port bits are named as PA0 to PA7. Similarly, PB0 to PB7. But PC0 to PC7 can be considered as a single 8-bit port or can be considered as two 4-bit ports. The lower 4 bits of port C, PC0 to PC3, can be considered a lower port C, 4-bit lower port C, and the upper 4 bits of port C, PC4 to PC7, can be considered as upper port C. So port C can be broken up into two 4-bit ports as well. Yes, so you can say that we can have three 8-bit ports or we can have two 8-bit port and two 4-bit ports with 18255 chip. Yes, so this is how you can connect your device, or this is basically your device side of the interface. Now coming to the system side of the interface, how this 8255 is connected with the system or the microprocessor. Now here, so basically how many ports we have in 8255? 3 ports. Yes. So each port should have an address. You want to send data to port A, or you want to send the data or communicate through port B. Send the data or receive the data depends on whether you have connected an input device or you have connected an output device. Yes. So, but this device is connected to which particular port, and always the port is identified by its address in AL,08. So 08 is the port address through which you want to get a 8-bit data onto your accumulator. Yes, or out 08, AL. You are sending data AL to a destination with a port address 08. So we need an address. Here, how many ports are there in 18255? 3 ports. So how many addresses? 18255 have 3 ports. Yes. So for each port, I need one unique address to identify that particular port. Port A should have a unique address. Port B have another address. Port C should have another address. So I have only 3 ports. So I need 3 addressable locations by 18255. So I need only 2 address lines. Yes. 2 address lines is required by 18255. Why? Because I need only 3 unique addresses to identify the port. But actually we need 4. Why we need the 4th one? We'll discuss later. we have 3 ports in 18255. To address these 3 ports uniquely, minimum 2 address lines are required. Yes, so 18255 should be connected to 2 address line on the system side. So 2 address lines of the microprocessor should be connected to the 8255 to locate or address these ports. Yes. So that is why we are writing A0 and A1. It requires 2 address lines. Which 2 address lines we will connect? We will go little later, not now. Then apart from that, it have read and write operation or signals. So it should be connected to which read and write signal of your microprocessor? IO read, IO write, or memory read, memory write? IO read, IO write. Yes, as it is a IO device, it should get selected only when there is a IO read or IO write operation. Yes, not during memory read, memory write operation. Now, if I am saying it so, I am defining my type of IO operation as isolated IO. Am I clear? If I am saying that this 8255 is connected to IO read or IO write signal of the microprocessor. So these 2 lines are connected with the IO read or IO write signal from the microprocessor. What it means? What it means? What it implies? That means this chip will operate only when the microprocessor is generating either IO read control signal or IO write control signal. When it will generate IO read or IO write control signal? Microprocessor. When it is in isolated mode of operation, yes, IO mapped IO or isolated IO operation, you have separate memory bank for your IO devices. If you are in memory mapped IO, in that case, your addresses are the part of memory bank and you are performing memory read and memory write even to access IO devices. Yes, so whenever I am saying this read and write signal, that's why it is left open. It depends on how we design our system. Whether I am going for memory mapped IO, 2 address lines from the microprocessor should get connected for addressing the 3 ports, port A, port B and port C available with 18255. Apart from that, the 8255 is connected with IO read, IO write or memory read, memory write signal from the processor. Here what we are looking at isolated IO. So I will write IO read and IO write signal. Hope it is clear. This signal may change. So if it is changing, you should understand why it is changing. Yes. And then it can have a reset signal. It is same as that microprocessor or any other chip have. You can reset your 8255 to its original value. I have used some set of IO device. Now I want to reprogram 8255. Yes. Or I want to bring 8255 to its initial state. So we will use reset pin. Apart from that, the very important part here we have is your chip select signal, chip enable, CS bar. Yes. Now when this CS or how this CS bar should work, where it should be connected. It is connected to the system side. If you see CS bar, I am representing on all these signals which we are representing is my system side of the interface. That means it is connected with the microprocessor. Yes, this side is your device side of the interface. The 8255 or this chip port is connected to the IO devices. Yes, so here this CS bar plays a very important role. How we have seen in your previous class, you have a latch or you have a buffer. That latch gets enabled. Under which situation? Only when there is a INTA bar signal and for a specific address only this particular buffer or latch should get enabled. Yes, I am communicating with a device which is connected to port A. That means the microprocessor has generated that address. Only for that address port A should get access. I have generated another address for, let us assume, port B. So only if that address is generated, at that time only port B should get accessed, not for any address. So that we are confining with the help of this chip select line. 8255 will get selected only when the address is any one of the addresses of these ports. Otherwise not. I may have multiple 8255 connected. Yes, I have a requirement of 8 or 10 IO device to be connected. Yes. Now, 8255 can connect maximum 3 8-bit device, but I have a requirement of 6 8-bit devices. I will use 2 8255. I have a requirement of 8 8-bit devices. We will use 3 8255. So, which 8255 you are going to select depends on this selection line. This selection line is connected to a decoder. That decoder will decode only for a specific addresses. We have done design for how we have done for memory. The way we have done for memory, for a specific range of address, one memory chip will get enabled. Yes, or will get selected. Exactly same way, for the addresses of these port, this 8255 should get enabled, not for any other address. Yes, and that is done through this chip select line. That means before this chip select line, I have a decoder. Decoder is connected to the address line from the microprocessor, and that decoder output gets low only if the address is between among any of these addresses. Hope it is clear. Apart from that, you have, as in the beginning I said, 8255 is a have 3 8-bit ports. So all these ports are communicating only 8-bit of data. So D0 to D7 is the data bus required or connected from the microprocessor. If I want to send 8-bit of data to port A or receive 8-bit of data from port A, so this communication happens through the data bus D0 to D7. 8255 have three 8-bit ports. 3 8-bit port. That means these ports are capable of transferring 8-bit of data. And that data will be transferred over. Now this is also optional. Over D0 to D7. This 8255 have given a name D0 to D7. Now if I am connecting 8088 processor, yes, it have only 8-bit data bus. You will directly D0 to D7 of 8088 will get connected to D0 to D7 of 8255. But if I have a 8086 processor, 8086 processor have 16-bit data bus. Now, which data bus you are going to connect? Whether lower data bus or higher data bus? It depends. We can connect D0 to D7 of your microprocessor 8086 to D0 to D7 of 8255, or we can connect either D0 to D7 or D8 to D15 of your microprocessor to the 8255, 8-bit 8255 data bus. 8255 have 8-bit data bus. If at all I am connecting my data bus of 8255 to D0 to D7 of 8086, which all addresses I can access? Lower data bus. It is quite similar to what we are talking about memory interfacing. IO mapped IO, you have a separate bank. Yes, you have a separate address IO bank. Yes. Now, if it is 8086 processor, my address needs to be divided into 2 banks, even bank and odd bank. Even bank is connected with data bus. Even bank is connected with data bus. Yes. D0 to D7. Odd bank, because even bank is enabled with A0. Odd bank is connected to D8 to D15 and it is enabled with BHE bar, bus I enable. Yes. So, this 8255 is either going to connect it to D0 to D7 or is going to connect it to D8 to D15. That means I can only access either even addresses or I can access only odd addresses. In the last class we discussed, that's why even if you have 8-bit address, you can connect maximum of 128 devices, not 256. If you have 8086 processor. Yes. Why? Because it is a 8-bit device. So you are going to use only half the data bus. I cannot use both data bus simultaneously. 8-bit device. Device is capable of transferring 8 bit of data only. And you are not going to access two devices at the same time with the same port address. No. That is possible with memory. I can access two memory locations. But here I cannot access two IO devices. Yes. So one IO device which is can transfer 8 bit of data. So that D0 to D7 bus either connected to the lower data bus of 8086 processor or connected to higher data bus of 8086 processor. So at a time either you are using even addresses or you are using odd addresses. If it is 8086 processor and your device is a 8-bit device. Yes. So depending on that, if you have an option of connecting D0 to D7 of the processor to the D0 to D7 of 8255 or D8 to D15 of your processor to D0 to D7 of your 8255. It can transfer only 8 bit of data. One port can transfer maximum 8 bit of data, not more than that. So this is what basically how your 8255 looks like or have its important components. It has three 8-bit ports. Port A and port B can operate only as a 8-bit port, whereas port C can be broken up into two 4-bit ports also. Port C have option to be used as a single 8-bit port or can be used as a two 4-bit ports. Now when we are talking about these ports, this is your device side. You can connect 8-bit devices to them or 4-bit devices or even 8 LEDs, 8 switches. So we'll come to the next slide, what these address lines do. Now when these two address lines, wherever you have connected any address line from the microprocessor side, when these two A0 and A1, I'm writing it is with respect to 8255, not with respect to the processor. Yes. Now A0 and A1, when it is goes 00, port A gets selected. Yes. So you want to communicate to port A. Then the address line A0 and A1 of 8255, this is 8255, should be 00. Whenever A0 and A1 is 00, port A gets selected. Whenever A0 and A1 is 01, port B will get selected. When it is 10, port C will get selected, and when it is 11, the fourth combination, it is a control register. You are communicating to control register. If you see the diagram here, okay, it is not shown. Here when we are writing this control logic, it is through control register. That detail I will show later. This 1 is for control register. You are communicating with control register, and control register is used to program 8255. Now it have three ports. Yes. How you want to program this? I have one input device and two output devices. I want port A to behave as an input device, input port, and port B and port C to behave as an output port. I want port A and upper port C to behave as an input port, lower port C and port B to behave as an output port. We have to program it. Yes, and that is done through the control register. You are programming your 8255 through control register. Yes, so control register is basically used to program your 8255 for different mode of operation. We'll come to that in little later. But these addresses, when I want to communicate through port A, my A0 and A1 will be 00, 01, for port C 10, and for control register 11. Here, if the port address, let us assume starting address I'm having 80, 82, 84, and 86. This will be the addresses generated. If my base address or starting address is 80, then the address generated by the processor will be 80, 82, 84, and 86. Why? Because I am going to use 8086 processor, and let us assume I am connecting D0 to D7 of the microprocessor to 8255. When you are connecting 80 to 87 of the microprocessor, in that case, which addresses we can access? Which addresses we can access? Only even addresses. Yes? Because A0 will be used for enabling the even bank. A0 will be used for enabling the even bank. Rest of the address lines can be used for addressing purpose. How you have connected your memory chip? Same way we are going to connect here. Here also I have two memory bank, even bank and odd bank. Even bank will be enabled with A0 and odd bank will be enabled with BHE bar. When A0 is 0, your even bank gets selected and you have connected D0 to D7 of the microprocessor to 8255. That means I want to access even addresses only. So actually A1 and A2 of your microprocessor will be connected to these two address lines of 8255. When this is connected and you are considering even bank, A0 is by default 0. A0 has to be 0 all the time, whatever address you generate now. Now I am telling my base address is 80. The port address, which is 8-bit address, I am using 8-bit address, fixed addressing mode. You can go for variable addressing as well. Yes? I am telling my first port address or base address is 80. That means the first port address generated should be 80. Yes? So when I want to write 80, it will be 10000000. Yes? This is A0 to A7. Now A0 cannot be used, A0 will be used for enabling the even bank. Yes. So the next lines, address lines available will be A1 and A2. A1 and A2 of the microprocessor. A1 and A2 of the microprocessor will be connected to these two lines of 8255. Now when this two line goes 00, port A is getting selected. Yes or no? So actual address generated is for port A will be 80. Yes. When this two line goes 01, A0 I cannot change because I am in even band. A0 has to be low. What I am looking is I have connected A1 and A2 of the microprocessor to A0 and A1 of 8255. So when this two line goes 00, the address generated will be 80. When this two line goes 01, the address generated will be 82. Yes, because A0 is 0. A0 is 0, so I am getting 00001. Yes, and other lines are same 10000010. So instead of generating 81, actually we generated 82 as the port address for port B. When this is 10, we are generating 84 as a port address for port C. When it is 11, we are actually generating 86H as the address, port address or address for control register. I will not take it as a port address, it's an address. Here we are not generating continuous addresses because you have connected a 8086 processor and we are using D0 to D7 of the microprocessor connected to 8255. Let us assume I have connected D8 to D15 of the microprocessor, 8086 processor to 8255. Then, and I am, what should be my base address, even or odd? First of all, you have to tell the first address, base address. Should be even or odd? Odd, let us assume I have my base address at 81H. Yes? Then, what are the addresses generated? 83, because for odd addresses, A0 has to be 1. Can I change A0? Can I make A0 0? If I am making A0 0, I am in even bank. I am not in odd bank. Yes? So A0 has to be 1. A1 and A2 of the microprocessor is connected to 8255, which can go 00, 01, 10 and 11 to select port A, port B, port C and control register. Yes? So the addresses in that case generated for each of these ports will be 81, 83, 85 and 87. Yes? So if it is 8086 processor, depending on which data bus you are using to connect your 8255, your addresses will be generated. And it will be either even addresses or odd addresses. We cannot have combination or continuous addresses. So this is how basically your address lines or addresses are generated for different ports and control register. Next, we will see the type of I/O transfer 8255 can handle. This is about 8255. So we can have a simple mode of data transfer, or we can have a handshake based data transfer as well with 8255. As you know, the simple mode of data transfer means the device, either you just consider a simple example of your switch or LED. They will transfer data. Yes, either you are getting data from a switch or you are giving data to a LED. Simple transfer of data transfer or simple mode of data transfer. Here, the second stage or cross verification is not done. Yes. So whenever the data is read from the processor, from the switch, it will be given to the processor, or whenever the data is sent from the processor, it will be given to the device. Yes. Simple mode of data transfer. Whereas the other mode which is also possible with 8255 is using handshaking. That means first the processor will check for the readiness of the device. You have seen wait state. Yes. First, it will check for the readiness of the device, whether the device is ready for data transfer or not. It is basically the input devices. Yes. Then it will go for data transfer, and in the third stage, it will verify whether the data transmission is successful or not. There may be loss of information before the data packets generally will check whether it is delivered completely or not. Yes, so that is possible with the help of handshaking. Whereas in simple mode of I/O transfer, data transfer, no checking of your device readiness or no cross verification of whether data delivered completely or not, it will not be done. Yes. So this is how we are going to program the 8255 control word format for 8255. So 8-bit, everything has to be 8-bit here. 8255 is a 8-bit port, you can say. So data transferred through 8255 is 8-bit. Either I am receiving data from 8255 or transferring data to 8255. Has to be 8-bit. So this control register, a control word, is written by the program. Yes, we are writing a program. So microprocessor sends a 8-bit data to the control register to configure or to program 8255. It defines the specific operation for individual ports. Yes, so this is the data sent by the processor to 8255. Control word is generated by the processor for the 8255 to configure or to program 8255. Yes, and it also has to be 8-bit data because you have connected D0 to D7 or D8 to D15 only 8-bit data. So this is a 8-bit format, 8-bit data. So this is a 8-bit format. D0 to D7. We'll start. D0 defines the lower port C operation. Now here we have to understand that port C can only operate in mode 0. There are different mode of operation. Mode 0. What is mode 0? Simple I/O transfer. The port is capable of doing only simple I/O transfer. It cannot do handshaking. Yes. So here port C can only operate in mode 0. Yes. And here port C can be broken up into two ports. We have port A, port B, and lower port C, upper port C. Yes. Port A, port B, lower port C, and or we can break up them into two parts, and one lower port C can behave as input or output, upper port C independently they can behave. Yes. So here we are talking, D0 talks only about lower port C. If D0 bit is high, lower port C is behaving as an input port. And if this D0 bit is low, the lower port C is behaving as an output port. It's written here, depending on the value we are setting. Yes. So if D0 is high, the lower port C is behaving as an input port. If the D0 bit is low, your lower port C is behaving as an output port. D1 bit represents port B. Now, port B is, this D1 bit is high. That means your port B is a input port same. This is same throughout. If it is high, it is input port. If it is low, it is output port. But port B can be operated in mode 0 or mode 1. Can operate in two different mode of operation. It can operate in mode 0. It can operate in mode 1. This is given by bit D2. If D2 is low, port B is in simple mode of operation. Mode 0 is simple mode of IO transfer, data transfer. Simple mode of operation. Mode 0 is simple mode of data transfer. That means port B is in simple mode of data transfer. But if D2 bit is high, it is in handshaking mode. Yes, so port B can be operated as an input port, as an output port, and it can transfer data in simple mode of operation as well as in handshaking mode of operation. So we have to program, we have to configure. Yes, depending on type of IO device you are connecting. Yes. Then comes your D3 bit. D3 bit is your upper port C. Now, upper port C can again independently operate as input port or output port depending on whether you are setting D3 as high or low. And it only, as I said, port C have only one mode of operation, no need of mentioning it. It can only operate in mode 0. There is no other possibility. Yes. Then comes the D4 bit, which is used for port A to configure port A. Actually, D4, D5 and D6 are used to configure port A. D4 represents whether port A is an input port or output port. D5 and D6 now represent whether it is operating in mode 0, mode 1 or mode 2. So, if you see, we can categorize like mode 0, all A, port A, PA, PB, PC. All the ports can operate in mode 0. Yes? Mode 0 is here, mode 0 is here, and port C can operate only in mode 0. So, all the three ports can go for simple data transfer. But port B, port A, PA and PB can go for mode 1 and PBA only can go for mode 2. What is mode 1? Handshaking. That means the device, readiness of the device will be checked, then data transfer will take place. At the end, we will verify whether the data delivered correctly or not. Mode 2 means bidirectional handshaking. Mode 2 is bidirectional handshaking. It's called as your bidirectional handshaking. That can be done if you have a device which requires bidirectional handshaking. You have to use only port A in mode 2. No other options. Yes. So it depends on type of input device now we want to connect. If it is a simple IO device, you connect anywhere. It will, and you have to, if you are connecting to port C, you can connect only simple IO device. Port C cannot be used for input device which requires handshaking. Yes. But if I have bidirectional handshaking requirement, I cannot use any other port except port A. So these are the limitations you can say, or these are the way this port operate or can be programmed. Then comes your last bit, D7 bit. D7 bit will be made high whenever we are programming 8255. To program, to write control word, D7 bit must be high. If D7 bit goes low, we are transferring some information to port C alone. That is not programming 8255. That is BSR mode. We will see later. Bit set reset mode of operation. But D7 bit must be high whenever we are programming 8255. That means I am writing a control word. We write control word to control register. This control word will be written by the microprocessor, sent to the control register of 8255 to program the ports in a specific mode of operation.